Solving trigonometric equations, part 1. In this video, we will talk about how to solve a trigonometric equation. And what is a trigonometric equation? It's an equation that contains a trigonometric function like sine, cosine, and tan. Now, here are some of the things that you must know before you go ahead and solve a trigonometric equation. So try to know as much of the unit circle as possible. And then you should also know the periods of sine, cosine, and tan functions. Now, I'll tell you quickly. Periods of sine and cosine are each 2 pi, and tan is pi. And in the unit circle, when you look at the unit circle, the coordinates, and also you've got to know at what angle in radian measure, because all of our answers will involve radian measures. Now, let's get into an example. We'll start with a simple one. Say sine theta equals half. Now, if you recall your unit circle, sine is the y coordinate, and the y coordinate is half and it's positive half. So there are two values where you're going to see sine theta equal to half. In the first quadrant, it's going to be pi over 6, and again, y coordinate is positive half. In the second quadrant, for theta equals 5 pi over 6. So these two angles we get from the unit circle. And also, what we have done is we have found the values of theta, or we solved this equation in the interval 0 to 2 pi. So in just one revolution. And I can say this. And sometimes the question will ask you to solve only in this interval, 0 to 2 pi. But if you want all of the solutions, then notice that sine has a period of 2 pi, which means sine repeats itself after 2 pi radians. So sine of pi over 6 is half, and sine of pi over 6 plus 2 pi, and then pi over 6 plus 4 pi, and so on, are all solutions. So once you find these two in one period, then you simply add multiples of 2 pi. So how do you write that? You say pi over 6 plus 2n pi, or theta equals 5 pi over 6 plus 2n pi. All right, let's look at one other example. Say cos theta equals negative root 2 over 2. Now, from the unit circle, we can find out what theta is. So cos is the x value, and x is negative in the second and third quadrants. And from the unit circle, we know that root 2 over 2 corresponds to 3 pi over 4. And then there is 1 in the third quadrant, which is 5 pi over 4. So just like here, what we have done is we have found solutions in this interval, 0 to 2 pi. And to get all of the solutions, I have to add multiples of 2 pi to each of these answers, because the period of cosine is also 2 pi. And I can say 5 pi over 4 plus 2n pi. Now let's look at one example where we have tan theta. So say I got tan theta equals negative root 3. Now tan is negative in the second and fourth quadrants, and from the unit circle, we know negative root 3, tan theta is negative root 3 in the second quadrant at this particular angle. And again, I need the angles in radians. So 2 pi over 3, and then this is at 5 pi over 3. Now, again, what we did is we found an answer in 0 to 2 pi. Now, I could just say that to get all the solutions, I just have to add plus n pi, because this time the period of tan is pi. And actually, if you notice, I don't even need this particular because this is included here. So for tan, you only want to go up to 0 to pi. So in that interval, if you find a value of theta, then you can get the solutions for tan theta. Now, sometimes you may have to do a little bit of algebra before. So say, sometimes it may say 2 cosine theta minus 1 equal to 0. So in that case, you add 1 on both sides first. So 2 cosine theta equals 1, and then divide both sides by 2. You get cosine theta equals half. And now you can say that theta is either cosine theta is half at pi over 3, or in the fourth quadrant, it's at 5 pi over 3. So now I can write down my solutions. Pi over 3 plus 2n pi, or 5 pi over 3 plus 2n pi. Now in the next video, we will look at more trigonometric equations where the algebra could be a little bit more complicated. You may have a quadratic in cosine or sine or tan.